So in this video, I'm going to show you how you can generate one type of split plot design in JMP. So I think, as far as I know, this can only work when your whole plot structure design is just a completely randomized design, and then your split plot structure is a um, complete block design. So this has to be a custom design. There's no split plot design option here for a general scenario. So I'm going to add, let's say, a categorical factor, and let's say that this is going to be this. Let's make this my whole plot factor, and let's say this has 4 levels. Let's just say that. So I'll just label this as whole plot factor, and I'll let L1 to L4 be my whole plot level. Now to tell JMP that this is going to be a whole plot factor, I need to say that the levels of this changes aren't easy, but they're hard. You can see very hard right here, so that you could actually do a split plot design, but that's a little beyond the scope of this course. So let's make that hard to change factor, and then let's add our split plot factor. Let's make this categorical, and let's say that this only has 2 levels, and we'll leave this as easy. Let me actually change this to split plot factor, just so that's obvious. So I'm going to click continue, and then this comes up. So notice the model it assumes is just a main effect model between whole plot and split plot. It's not assuming that we want to estimate interactions, so I'm going to change that. I'm going to say, let's include the second order interactions, just so JMP knows that that's what I'm interested in doing. Then it says number of whole plots. I really don't know how it comes up with 6. So the number of whole plots should be related to the number of levels. So if I do 6 whole plots, then it should do each one of these replicated 1 time, and then 2 of them replicated twice. So it makes more sense that we might want to have this be an equally replicated design for the whole plot factor. So let's make this, 12, so that each of these is replicated 3 times each. And that's just going to be something that JMP does by default. It's going to encourage equal replication between these. Now, if I want to manipulate the split plot factor, how many levels are at the split plot level, I need to go down to a number of runs. So this is always going to be some multiple, ideally of 12, because we're going to have the same number of split plots for every whole plot. So if I do 36, this is saying 3 split plots for every whole plot, which again seems a little unusual to pick because we have 2 levels at my split plot factor. So why don't we do just a complete block design for each whole plot. So that means 2 split plots per whole plot, or 24 total runs. So this should give me an equally replicated CRD at the whole plot level with 3 replicates, and a complete block design at the split plot level. So I'm going to click Make Design, and so it takes a little time for JMP to compute the design. Again, it's searching for it, but hopefully it should find the design that I just described. So let's see. All right, so it pops up. And so this is how it is structured. So here we have the whole plot factor, and so they should have the same whole plot factor for each whole plot. So we have treatment 1 replicated 1, 2, and then 3 times. Treatment 2 is replicated 1, 2, and then 3 times. And we see that also holding for treatment 3, and then treatment 4 3 times as well, which is what we want. And so we always should have L1 and L2 generated the same number of times in each whole plot, which looks like that's exactly what it's doing. So it is giving us the design we want. It just didn't arrive at that theoretically. It just kind of did it algorithmically, but it was able to find the right design anyway. So you should be always a little bit skeptical when JMP is doing this algorithmically. You could have, by random chance, rather poor design. You might just want to check out the design evaluation. The color map correlations are helpful. So ideally what you want to see is everything blue on the outside, because that indicates orthogonality, which in this case is what we should be able to achieve with this type of design. When these things aren't perfectly blue, it might be because you can't get a nice design at the whole plot and a nice design at the split plot. But if you know you can, then that means Jump wasn't able to find really the best design. So we click make table. But actually before that, one thing that's really nice about Jump is you can generate fake data. So you can simulate responses. So nothing pops up here, but when I click make table, it's able to give you the simulate responses. So it kind of has some model terms here. So we'll just hit apply and we won't worry about it. But if I go to analyze fit model, it's going to have the model for you. And so here it's generating my whole plot error terms by making the whole plot factor random. I think if you change this to EMS, it is actually going to do this. This is actually going to give you the wrong model. So it's best to stay with REML with the model that Jump gives you. So you click run, and it's able to analyze the data the correct way. So it doesn't seem like there's a way. I know there was a way to add blocks in the custom design feature, but when I tried that out, it didn't give me a blocked whole plot factor, so it doesn't seem to work. But if you just need to do a split plot design where you have a completely randomized design at the whole plot level and some sort of block design at the split plot level, this seems to be doing a pretty good job.